Assalamualaikum YouTube viewers. The topic of today's video is radiation dosimetry. So in this video I am going to describe what is radiation dosimetry and the types of the dosimetry. Okay, so moving on, first of all, what do you know about radiation dosimetry? Okay, so radiation chemistry is actually a subdivision of chemistry. Okay, it is actually the subdivision of the nuclear chemistry, which is a study of chemical effects of radiation on matter. Okay, so what we study in radiation chemistry, it is actually the study of the chemical effects of radiation on the matter. So if I have some matter here, okay, let's just say that this here is a matter and a radiation falls on this matter. Okay, so this radiation that is falling on this matter will produce some effects, some chemical effects on this matter here. So due to the falling of this radiation on this matter, some chemical effects are produced. So the study of those chemical effects that are produced on this matter due to falling of this radiation is known as the radiation chemistry. Okay, so that was the definition of radiation chemistry. So moving on towards radiation dosimetry. So what is radiation dosimetry? So radiation dosimetry is in the fields of health physics and radiation protection. Okay, where radiation dosimetry is used, it is actually used in the field of the health physics. Okay, it is used in the field of health physics and radiation protection. Okay, so radiation dosimetry is actually the measurement, the calculation and assessment of the ionizing radiation dose absorbed by the human body. Okay, so what is the radiation dosimetry? It is actually the measurement. Okay, it is actually the measurement and the calculation and the assessment of the ionizing radiation, the amount of the ionizing radiation, okay, that is absorbed by the human body. So if we are studying, if we are calculating, if we are measuring the amount of the radiation dose that is absorbed by the human body, then this is known as the radiation dosimetry. Okay, so the next thing that we have is this applies both internally due to ingested or inhaled radioactive substances or externally due to irradiation by sources of radiation. Okay, so how the radiation is absorbed by the human body, it can be through internal means. Okay, so actually we ingest some substances that are radioactive substances. So the ingestion of radioactive substances or inhalation of some radioactive substances result in the internal dose of radiation. Okay, and externally it can be due to the external source, like if we are working in an environment where there are a lot of radioactive substances, so in that case I'll be exposed to a lot of radiation, so that is my external radiation dose. Okay, so that was my radiation external dose. So moving on towards the next slide. So what I have here is the types of dosimetry. So in this slide I am going to explain the types of dosimetry. First of all, internal dosimetry. Internal dosimetry is the science and art of internal ionizing radiation dose assessment due to radionuclides incorporated inside the human bodies. Okay, so what we are studying here in internal dosimetry is the science and art of internal ionizing radiation dose assessment. Okay, what we need to do is to measure, is to study the internal ionizing radiation dose. Okay, the radiation dose that is present inside the human body. What we have done, we have just ingested or inhaled some radioactive substance, and the radioactive substance is present inside our body and is producing some radiations. So in internal dosimetry, what we have is the measurement of the internal ionizing radiation dose that is present inside the human body. Okay, and well is external dosimetry. Okay, what is external dosimetry? External dosimetry is based on the measurement with a dosimeter. Okay, so what we do is in external dosimeter we use a dosimeter, in external dosimetry we use a dosimeter. Okay, or inferred from measurements made by other radiological protection instruments. Okay, so external dosimetry, as you know, is due to some external source, okay, that is not present in the human body. External dosimetry is due to the external source that is not present in the human body. So such a dosimetry is calculated, is measured through the dosimeter or through some other radiological protection instruments. Okay, or through some other radiological protection instruments. Okay, so the next thing that we have is the other significant areas are medical dosimetry. Okay, so what we have studied here is internal dosimetry, external dosimetry, and the next thing we are studying here is the medical dosimetry. So in medical dosimetry, as you know that in chemical therapy, okay, in chemical therapy we use the radioactive substances. Okay, similarly in the field of medical, for curing cancer, for example, we use the radioactive substances, we use the radiations. Okay, and for a lot of different purposes in the medical areas we use the medical dosimetry. Okay, so that's the medical dosimetry. And the next thing is we have environmental dosimetry. So what is environmental dosimetry? Environmental dosimetry is used where it is likely that the environment will generate a significant radiation dose. Okay, so if we have some significant radiation dose in the environment, what we use is the environmental dosimetry. So in environmental dosimetry we study the radiation dose that is generated by the environment, okay, such as radon monitoring in buildings. Okay, what radon is here? Radon is some radioactive substance, and radon monitoring in buildings mean that in buildings there is the release of radon radioactive rays. Okay, there is a release of radioactive rays from radon chemicals. So what we do in environmental dosimetry is just to measure the amount of the radioactive rays, the amount of radioactivity that is being released by the radon. Okay, so that was our environmental dosimetry. So moving on, what we have here is external dose. Okay, so in this slide I'm going to explain the external dosimetry or external dose. So there are several ways of measuring the absorbed doses. Okay, so there are several ways of measuring the absorbed doses from ionizing radiation. Okay, so people in occupational contact with radioactive substances or who may be exposed to radiation routinely carry personal dosimeters. Okay, so what we have is people who are in occupational contact with radioactive substances, okay, who are in contact with radioactive substances may be exposed to radiation, because as you know that radioactive substances the radioactive substances release the radioactive rays. So I can say that if a person is working in a place where there are a lot of radioactive substances, then he can be in contact, then he can be exposed to radiation. Okay, so what do such persons do? Such persons carry a personal dosimeter. Okay, such persons carry a personal dosimeter. So these are specifically designed to record and indicate the dose received. So what is the working of the personal dosimeter? It is actually specifically designed to record and indicate the dose received. Okay, so a person who has a personal dosimeter will continuously take a look at the dosimeter to see how much radiation is he receiving right now. Okay, so the next thing that we have is, traditionally these were lockets fastened to the external clothing of the monitored person. Okay, so first of all, what were these personal dosimeters like? These were like the external, these were like the lockets. Okay, these were like the lockets that were fastened, that were attached to the external clothing of the person. Okay, which contained, so what was present in these lockets? The lockets contained the photographic film known as the film badge dosimeter. Okay, so the locket had a film badge dosimeter. Okay, here it is an example of a dosimeter. Here you can see it is a personal dosimeter. Okay, so the next thing that we have here is, these have been largely replaced with other devices. So these lockets has now been replaced with some other devices such as TLD badge. Okay, so what is TLD badge? TLD badge is actually a thermoluminescent dosimetry. Okay, so what is thermoluminescent dosimetry? A thermoluminescent dosimeter, or TLD, is a type of the radiation dosimeter. What it is? It is actually a type of the radiation dosimeter. Okay, so a TLD measures ionizing radiation exposure by measuring the intensity of visible light. Okay, so how TLD works? A TLD measures the ionizing radiation exposure. Okay, it measures the radiation exposure, okay, by measuring the intensity of visible light. Okay, how does it measure the radiation exposure? It measures the radiation exposure by measuring the intensity of the visible light emitted from a crystal inside the detector when the crystal is heated. Okay, so what you need to do is to just to listen it with full concern, listen it with full attention, that first of all, the intensity of light emitted by the crystal present inside the TLD is directly proportional to the radiation exposure. Okay, so if I have more radiation exposure, then more light is emitted by the crystal present in the TLD, and in this way it can tell the amount of the radiation that is being exposed to a person. Okay, so that was our TLD. So moving on, what I have here is a number of electronic devices known as the electronic personal dosimeters have come into general use using semiconductor detection and programmable processing technology. So what we have is now we have electronic personal dosimeters that are normally used. They use the semiconductors. Okay, what they use is the semiconductors, and they have programmable processing technology. So these EPDs are worn as badges. Okay, so these EPDs are worn as badges, and what they do is they indicate the instantaneous dose rate. Okay, they indicate the instantaneous dose rate, the amount of dose that is absorbed at any instant by a person. Okay, so these badges give an indication of the instantaneous dose rate. Okay, so these badges give an indication of the instantaneous dose rate, and if the dose rate exceeds, okay, if the dose rate exceeds some limited value, then these dosimeters, then these APDs give a visual or audible alarm. Okay, so these devices are particularly useful for the real-time monitoring and are used in those areas where a high dose rate is expected. Okay, where there is the expectation that there will be a high dose. Okay, so which will time limit the wearer's exposure. So when there is a high exposure, then the alarm will beep. Okay, and when the alarm will beep, the person will know that he has been exposed to the radiation for so very much long time. Okay, so he will leave the radiation area. So in certain circumstances, what we have is a dose can be inferred from readings taken by fixed instrumentation. Okay, an area where the person is working, that area, that institution will also have some fixed instrumentation that will measure the dose, that will measure the radiation dose emitted. Okay, so these fixed instrumentation usually used in the area where there are no personal dosimeters. Okay, so if a person do not has a personal dosimeter, then he can regularly check the fixed instrumentation for the radiation dose. So such calculation would take a pessimistic view of the likely received dose. So we can calculate the received dose through this. Okay, so the next thing we have is internal dosimetry. So internal dosimetry is used to evaluate the committed dose due to intake of radionuclides into the human body. Okay, so what we do is we ingest or we inhale the radioactive nuclide. Okay, and these radioactive nuclide, when present inside the body, then they can be source of radiation. So this is all about the internal dosimetry. Okay, so the next thing we have here is medical dosimetry. Medical dosimetry is the calculation of absorbed dose and optimization of dose delivery in radiation therapy. So what we do in medical dosimetry is actually to calculate the absorbed dose. Okay, what we do is we calculate the absorbed dose and we optimize. Okay, we optimize the dose delivery in radiation therapy. Okay, so what we have next is here, it is often performed by a professional health physicist with specialized training in that field. Okay, so in medical dosimetry is performed by a person who has specialized training in the medical dosimetry. Okay, so what we have next is, in order to plan the delivery of radiation therapy, the radiation produced by the sources is usually characterized with percentage depth dose curves and dose profiles measured by medical physicist. Okay, so the medical physicist, the professional who has a degree in medical dosimetry, okay, who has a degree in medical dosimetry will measure the amount of radiation that is to be given to a patient. Okay, and he will measure through different techniques like percentage depth dose curves and dose profiles, etc. Okay, so that will be done by the medical physicist. So the next thing that we have here is the environmental dosimetry. Okay, so environmental dosimetry is used where it is likely that the environment will generate a significant radiation dose. Okay, so environmental dosimetry is used where there is likelihood that my environment is generating a significant radiation dose. Okay, so an example is that that of the radon monitoring, as we have described it earlier. So what happens here is, so what is radon? Radon is actually a radioactive gas. What is radon? Radon is actually a radioactive gas that is generated by the decay of uranium. As you know about uranium, that uranium is a radioactive substance. So radon is a gas that is being generated by the decay of the uranium, and which is present in varying amounts in the earth's crust. So this radon gas is present inside the earth's crust. Okay, so this radon is present inside the earth's crust. So certain geographic areas, due to underlying geology, continually generate radon. Okay, so in certain geographical areas we have these areas generate the radon gas, okay, which permeates its way to the earth's surface, and this radon gas that is generated by the earth comes out onto the surface. Okay, so then it can be the cause of radiation. Okay, so what we do here is a number of specialized dosimetry techniques are used to evaluate the dose that a building's occupants may receive. So there are a number of techniques that people use to evaluate the dose that the occupant of buildings, that the people who are living inside the building may receive. Okay, so in this slide, what I'm going to discuss is the units of dose. So what are the units of dose? The absorbed dose is actually measured in grays. Okay, the absorbed dose is measured in grays, and which is equal to the energy absorbed per unit mass, okay, which is equal to the energy absorbed per unit mass. The unit of energy is joule, so, and the mass has a unit of kilogram, so it becomes joule per kg, okay. And equivalent dose H is measured in sieverts, and similarly effective dose E is also measured in sieverts, and karma is measured in grays again, and each measure is often simply described as dose, okay. So each of these measure is often simply described as a dose. So moving on towards the next slide, what we have on the next slide is the types of dose, okay. So in types of dose, we are going to explain the types of different doses. First of all, we have is absorbed dose. So what is absorbed dose? Absorbed dose is actually the amount of energy absorbed by the radiation in a mass, okay. So it is the amount of energy absorbed by deposited by the radiation. It is actually the amount of energy deposited by the radiation in the mass. So if I have a mass, okay, and if I have a radiation mass that is falling on this mass, okay, so if I have this radiation that is falling on this mass here, this radiation will deposit some energy on this mass, okay. This mass will absorb some energy due to this radiation. So the amount of energy that is absorbed by this mass due to this radiation, okay, due to this radiation, the amount of energy that is absorbed by this mass is known as the absorbed dose, okay. So that was the definition of absorbed dose. So moving on towards the equivalent dose, okay. So what is equivalent dose? So equivalent dose is actually measured for individual organs, okay. So the equivalent dose is measured for the individual organs and is based on absorbed dose to an organ, okay. So if I talk about the equivalent dose, then I'll be talking about the amount of radiation that is absorbed by one organ at a time, okay. So equivalent dose is equal to the absorbed dose, okay. It is equal to the absorbed dose multiplied by the radiation weighing factor, okay. So equivalent dose is equal to absorbed dose by an organ multiplied by the radiation weighing factor. So what is radiation weighing factor? It is actually needed because different radiation produce different effects even if absorbed dose is the same. So if I have different radiation, like if I have an X-ray, if I have a gamma ray, okay, so if I have different types of radiation, then these different types of radiation will produce different effects even if they are absorbed in the same amount, okay. Even if they are absorbed in the same amount by an organ, these radiations, these different type of radiation will produce different effects, okay, different level of effects they will produce. So the equivalent dose will be equal to the absorbed dose by an organ and multiplied by the radiation weighing factor. So equivalent dose is equal to absorbed dose by an organ multiplied by the radiation weighing factor. So the next thing we have here is the effective dose. So what is effective dose? Effective dose is measured for the whole body, okay. As equivalent dose is measured for a single organ, then effective dose is measured for the whole body. It is the addition of equivalent doses to all organs, okay. What it is actually the addition, it is actually the it is actually the addition of the equivalent doses to all the organs, okay. As you know that our body is made up of different types of organs and different organs absorb radiations, okay. If I am exposed to some environment, then all of my organs will absorb the radiation, okay. If I add up all the equivalent doses of each organ of my body, then it becomes the effective dose, okay. So effective dose is actually the sum for all organs, okay. So it is actually the sum for all organs, and what the sum is for, the sum is of the equivalent dose to organ, okay. So equivalent dose to an organ, the formula for equivalent dose to an organ we have read earlier, that absorbed dose multiplied by the radiation weighing factor. That was a formula that we have read in equivalent dose. So what we have in effective dose is the sum for all organs. What we take is the sum for all organs, and what is the sum for? The sum is of the equivalent dose to an organ multiplied by the tissue weighing factor, okay. So it is actually the equivalent dose to an organ multiplied by the tissue weighing factor. So what is the tissue weighing factors? Just like the previous in equivalent dose, what we have read about was the radiation weighing factor. Similarly in effective dose we are reading about the tissue weighing factor. So tissue weighing factor, why it is required? Tissue weighing factor is required because the different organs have different levels of sensitivity to radiation, okay. Different organs have different level of sensitivity to radiation, so we require our tissue weighing factor, okay. So that was all for today's video. Thank you and Allah Hafiz. If you have any question, you can ask in comments, I'll reply. And secondly, do not forget to subscribe the channel. Inshallah, see you in the next video. Allah Hafiz.